Good morning, everyone. We are the Group 4.
And we will conduct the determination of optimum moisture content using Standard Proctor Test.
So these are our laboratory equipment. First is the compaction rammer, the mold assembly, the rubber mallet, the number 4 sieve, the coarse grained soil sample, and the metal pan.
Using a rubber mallet, crush and pulverize the coarse-grained soil sample in the metal pan. Depending on the type of mold you're using, obtain a sufficient quantity of air-dried soil in the large mixing pan. For the 4-inch mold, take approximately 10 pounds, and for the 6-inch mold, take roughly 15 pounds. Pass enough of the pulverized soil sample through the number 4 sieve. Cover the sieve and shake to remove the unwanted large particles. Determine the weight of the compaction mold with its base and without the collar by using the balance and record the weights. Also, record the weight of the water container to calibrate the measurement. Next, determine the weight of the soil by carefully transferring the sieved soil sample into the compaction mold. Since we are using a 6-inch diameter mold, the dry soil should be around 15 pounds. Measure the water that will be added to the soil. Carefully add water in the container until the desired initial amount of water is reached. To compute the amount of initial water, assume water content for the first test to be 8%. Next, measure out the water, add it to the soil, and then mix it thoroughly into the soil using the trowel until the soil gets a uniform color.
The next step is place the mixture into the mold. Next step, compact the soil in the number of equal layers specified by the type of compaction method employed. In this experiment, we divided it into 3 layers, and in each layer, we executed 25 blows from 5 directions of the mold, namely south, north, east, west, and in the center. Next step is to remove the collar trim and remove the excess soil to even the top of the mold with a straight steel edge. And in this case, we used a trowel. Also, clean the outside of the mold and the base plate. And the next step is to weigh the soil by subtracting the weight we got from the mold. After the first trial, remove the soil from the mold and add additional water to increase the moisture content percentage. And then, just repeat the same compaction procedure until such time that we can see a certain decline of the soil density with the increase of the water content.
Chocolate cake.
Sila ito, 10 to 100. For the results and discussion, after we calculate the wet mass of soils in grams, we found out that in the 8% water content, it has a 3,525 wet mass in soil, and in the 10% water content, it has 4,005 grams. In the 12% water content, it has 3,855 grams. In the 16% water content, it has 3,715 grams. And in the 20% water content, it has 3,655 grams. Next, this is the optimum moisture content graph. As you can see in the graph, in the 8% water content, it has a dry density of 1.76 grams per cubic centimeter. And in the 10% water content, it has 1.96 dry density. And in the 12% water content, it has 1.86 grams per cubic centimeter. And in the 16%, it has 1.73, and in the 20%, it has 1.64. The 8% of water addition in the soil sample is served as our base point in the experiment, or the sample 1, and it has a dry density of 1.76 grams per cubic centimeter. And after we added an additional water and bring it to 10% water content, we found out that the dry density is increasing. And after further addition of 2% and bringing it to 12% water addition, or water content addition, it has a 1.86 dry density, and it shows that the value of dry density is decreasing. And to confirm that it is really decreasing, in the sample 4, we added 16% of water content, and the dry density is 1.73 grams per cubic centimeter, which is lower than the sample 3. And to really confirm our claim that the dry density, or the maximum dry density, is in the 10%, we did our 5th sample, which is 20% water content addition, and it has a dry density of 1.64 grams per cubic centimeter. And this shows that Our optimum moisture content is 10% and our maximum dry density is 1.96 grams per cubic centimeter, and this was highlighted in the vertical and horizontal line in the graph. There's no really standard for the maximum dry density and the optimum moisture content of the soil since it differs in several factors, but upon comparing to the example given by AASHTO T180 moisture density relation of soils, which is the basis of our procedure, we found out that their results is similar to our results. So in conclusion, the 10% water addition is the optimum moisture content in that particular soil sample. Adding below or higher that level will result a decrease of dry density to the soil.